So going into the next question of the day, we're looking at Doppler, and this comes from November 2019. And this is quite a tough question, I'm not going to lie, and you're going to see it's actually working with simultaneous equations. So this becomes your level 4 question. Now, fortunately, only about 10 to 12% of your paper will be higher order level 4 type questions. But yeah, it still takes a little bit of thinking, but you can do this. All right, so let us have a look at the question. And I would like to ask that you take a photo of the question maybe, because there are some graphs that we need to look at. So let us go into the question. All right, it says, well, let me first let you take a photo. So there's the first part, there's the one graph, and there's the second graph. All right, so I hope you've got that. So they're giving us a few patterns there. And it says the siren of a police car, which is traveling at a constant speed. So once again, I see we've got these words, constant speed, along a straight horizontal road, emits sound waves of a constant frequency. A detector P is placed inside the police car, and detector Q is placed next to the road at a certain distance away from the car. The two detectors record the changes in the air pressure readings caused by the sound waves emitted by the siren as a function of time. The graphs below were obtained from the recorded results. Okay, so now they've given us the graphs, and they say graph A is the air pressure versus time recorded by the detector P in the car, and graph B is the air pressure versus time recorded by detector Q, which is next to the road. So I see detector Q next to the road just means it's going to obviously be stationary. So this is basically the listener, as it were. And this is going to then obviously be the car with the source. And so as the car's moving, if it's got a siren, that's more than likely going to be the frequency of the source. But let us have a look. I'll notice the graph here. So here's full one wavelength. So remember, when we are working with these, we're looking at, oh, it's wonky, looking at one full wave. So it is looking at a crest and a trough, and that makes one full wave. And it took 17 times 10 to the minus 4 seconds to make that one wave. All right, so that's important. And if I have a look at graph B, I see here is my full wave, and that is made in 18 times 10 to the minus 4 seconds. Okay, so let us have a look. It says different patterns are shown for the same sound wave. So that is the same sound wave, just recorded by the different detectors. The one in the car, the one outside next to the road. Right, and it says what phenomenon is illustrated. So obviously this is going to be the Doppler effect. So that's a nice easy 1 mark. So Doppler effect, and there we go. Now we go into the next question, and the question says use the graphs and give a reason why it can be confirmed that the police car is moving away from detector Q. Now, looking at the graph, what I would suggest is to actually have a look at those frequencies if you wanted to. So what you'll see is that Q is going to have a lower frequency, all right, and as a result of that, we're going to see that therefore it is going to be moving away. But let us have a look. So what I want you to do is to look to the graph and go calculate what is 1 divided by 17 times 10 to the minus 4. So we need to look. So remember, frequency is equal to 1 over the period. All right, now that is given to you. Let me just show you on the information sheet quickly. Here it is here. Let me just change my color pen. Here it is here. T is equal to 1 over F, which means that F is equal to 1 over T. So let's go back to our question. Sorry, wrong question. Now, oh dear. All right. So now we know that frequency is equal to 1 over time. All right. So we saw that the first one was at 1 divided by 17 times 10 to the minus 4 versus 1 over 18 times 10 to the minus 4. So let us have a look at those frequencies. So now we need to go calculate. So let's have a look. So what is 1 divided by 17 exponent minus 4, and that is going to equal to 588,24. So let us write that down. So this is 588,24, and that is hertz. All right, let us just work out the next one quickly. So the next one was 1 divided by 18 exponent minus 4. What is that equal to? And that is equal to 55,56. So that's 555,56 hertz. All right. So I can see, therefore, that this one, Q, is less than. All right. So Q is less than this one, and therefore Q is going to have the lower frequency. So this was for Q, this was for P. So Q has a lower frequency, and because Q has a lower frequency, it means it's moving away. All right, so quite a lot of work in interpreting. So remember, don't forget, frequency is equal to 1 over the period. Work out the frequency if you can't see it, because we know if the frequency is increasing, it's moving towards us. If the frequency is decreasing, it's moving away. So you just learn that. So how can I work out this question? Go calculate the frequency for both, and you can see Q is going to be lower. All right, so you don't have to guess. You really don't. You can actually work it out. All right, but don't forget to use the times 10 to the minus 4. So that's critical. And that's also very common in the photoelectric effect. So watch that x-axis when we're working with frequency and time, that we don't forget to use those times 10 to the minus whatever they have given us. All right, let's look at the next question. All right, the next question says calculate the frequency of the sound waves recorded by detector P. Well, we've already done that actually, but let us just do it again. So we know frequency is equal to 1 over T, and we found for the detector T, P, it was 17 times 10 to the minus 4, and 10 to the minus 4 was equal to 588,24 hertz. So that was nice and easy, and a nice 3 easy marks. Okay, next question. So here's our higher order question. All right, so gone too far. So this is the biggie. All right, so it's for 6 marks. So this is clearly the higher order. This is the level 4 question. All right, so let us have a look what they're wanting us to calculate. So it says the police car is moving away from detector Q. Use the information in the graphs to calculate the speed of the police car and take the speed of sound in air as 340 meters per second. All right, so we're going to start. We're going to have the frequency of the listener equals V plus or minus Vs over V plus or minus VL multiplied by the frequency of the source. All right, so always start off by writing out your equation. At least you get 1 mark for that. So even if you get really stuck, you can get a mark. So you need to use it. You need to substitute into this to get the marks. All right, so we are going to now work out for detector Q. So the frequency for detector Q, so detector Q was actually the listener in this instance. All right, so the listener was that detector Q. So we're going to substitute in for that the frequency for the detector. And we calculated, I think it was 555. All right, so let us substitute. So this was 555, I think it was 56, is equal to V is 340. Now the source at this point was standing still. The velocity of the air is 340, they told us. And now we're going to say plus V multiplied by the source, and the source we know was at 588,24, I think it was. All right, so we're just subbing in for what we have. All right, so now you're going to have to do exactly the same for your other equation. All right, so once we've got that, we can then cross multiply and we can solve. So let us have a look. I think the simplest would be to get rid of the 588. So we go 555, 56 divided by 588,24 is equal to 340 over 340 plus V. Oh, I see this wasn't actually a simultaneous, but okay, fine. We're going to make this simple. Let's just multiply this out quickly. So this was 555.56 divided by 588.24. And that gives us 0.944. And now what I want to do is just to simplify it. So let us take the 340 plus V across is equal to 340. Now we need to multiply out here. So 0.944 multiplied by 340. We're applying the distributive law. And this is 321,11 plus 0.944V equals 340. Now it's just a matter of simplifying. So it's 340 minus 321,11 is equal to 0.944V. And then we put that into our calculator and we should get an answer of about 19,79 meters per second. And you can just go and check me. So I hope my maths is correct and you can go and check me. So this is really a little bit different, a little bit tough, but simple mathematics. So you use the equation, you substitute into it, and then you solve. All right, and then don't forget, we need to just check that we have substituted correctly, frequency of the listener, frequency of the source, that we have substituted into the correct positions, and then you should be fine.